circumferences of circles and areas of circles. I know we just finished the circle unit, but this is kind of a continuation as we head into area and volume of two-dimensional, three-dimensional shapes. These are not new topics, but sometimes we're presenting things a little differently. For example, we're going to use generally the formula circumference equals pi times diameter instead of the traditional pi, circumference equals 2 pi r. And the reason is because people often mix this up with the area equals pi r squared formula. We can see how those two formulas can easily be mixed up because they both involve a pi and r and a number 2 in different contexts. So in order to avoid confusion, we generally just go with pi times diameter as our formula. Now, the other question that always comes up is when do we approximate pi as 3.14, and when do we just go ahead and leave it as a pi, leave answers in terms of pi? And generally, we leave things in terms of pi when it is practical to do so. So if I'm giving something like, I don't know, a problem like this, find the circumference of a circle with 9 centimeters. Okay, well, I'm sorry, radius of 9 centimeters. So if r equals 9 centimeters, the diameter is 18 centimeters. So the circumference is simply 18 pi centimeters. And we leave it in terms of pi. We don't approximate pi because there's really no need to. If somebody needs to approximate pi, it's very easy to multiply 18 times a decimal approximation and get that number. But when we have a nice whole number diameter like that, there's no reason for us to approximate pi. We can give a precise answer. You'll also note that I use my units here. One thing that we emphasize a lot in stats is answers need to have context to be meaningful. And the same applies in geometry. Our units are context. We want to make sure we give our answers in the correct context. To contrast that, sometimes we'll look at something like this. This is a backwards problem. We're looking for the radius given the circumference is 26 meters. Meters being our context. So circumference equals pi times diameter. Now here, because we're given the circumference as a whole number, and we need to solve for the diameter, I have to divide by pi. Now dividing by an irrational number, if this was 26 pi divided by pi, that would be easy. The pi's would cancel out. But since it's just a whole number, this is a situation where it makes sense to probably approximate pi. So 26 divided by 3.14, because we don't like dividing by irrational numbers. It's about 8.28 equals the diameter. But we know the diameter, we don't want the diameter, we want the radius. So I have to divide that by 2 again to get the radius. So that's 4.14. Give the context, meters, equals what? The radius. So make sure you don't just write 4.14 for an answer here. 4.14 units equals, give me the full context of your solution. Let's try a little more. Diameter is 5 inches. Here, they give you a nice whole number diameter. It would make sense to leave my answer in terms of pi. And circumference is just pi times diameter, so that would be 5 pi. Circumference equals 5 pi inches. Our answer is given in full context, circumference, inches. Find the diameter of a circle with circumference of 17 feet. Okay? Again, circumference equals pi times diameter. We got 17 equals pi times diameter. We're going to divide by pi, but having a pi in the denominator is not neat or clean, so we go ahead and decimally approximate. 17 divided by 3.14 is 5.41 equals the diameter. Notice we're always going to 2 decimal places when we're approximating. That's a general rule of thumb. Since we approximate pi at 3.14, we stick with that 2 decimal place. What did I forget here? I forgot my context. Shocking. 5.41 feet equals diameter. All right, we've done that. Now you give it a try. Circle is a diameter of 18 meters. Find the circumference in terms of pi. The other thing we're going to talk about today then is the area of a circle. The area of a circle is used as a formula pi r squared. Again, this is not new. You've done this many times. But again, you notice that we did differentiate in the formulas. R is the radius of the circle. So area equals pi r squared. It's not 2 times r. 2 times r is diameter. That's the formula for circumference, r squared. We have to take r times r. So notice the decimal values here. That probably means we're going to be approximating pi in our solutions. So if I want to find the area of a circle with a radius of 2.5 centimeters, the area is going to be 3.14 times 2.5 squared. Now, order of operations says I have to do it to the exponent before the multiplying, so 2.5 squared, and then times 3.14 gives me 19.625, since it's precise, 25 centimeters squared. Again, context, units, and it's units squared because it's an area. We know area is measured in units squared. The diameter of a circle with area 113.1 square centimeters. Okay, so this is the same formula. Area equals pi r squared, except it's a little more complicated because of the squared. We still plug the 113.1 in for the area. The pi I'm going to make 3.14 times r squared. And you divide by 3.14. So 113.1 divided by 3.14 is 36.02 equals r squared. But I don't want to know what r squared is. I want to know what the radius is so I can find the diameter. So in order to solve for the radius, I'm going to have to take the square root of both sides. So square root of 36.02 is about 6.00. So if that's the radius, we want to find the diameter. So the diameter is going to be 2 times that, or 12 centimeters. And it's not centimeters squared because diameter is a length. So context is length units, which is not squared. Find the area of a circle with a radius of 5 meters. Leave your answer in terms of pi. Notice, since it's a nice whole number radius, leaving in terms of pi is the appropriate thing to do. So pi r squared is pi times 5 squared, which is 25 pi meters squared. Answer, context. Finally, the radius of a circle with an area of 176.7 square feet. Notice the decimal value, so decimal is approximate, is what we're going to be looking for, a decimal value. And you go ahead and solve that on your own, and thus ends our podcast for today.